Hi, welcome to Mrs. Thompson's classroom today. Today's lesson is on rational equations. Rational equations are those that include fractions, but specifically these fractions have a variable in the denominator. Now that means they're going to have a restriction to them. So the first thing we're going to be looking at is how to solve these equations. But sometimes these equations will come out with a solution that doesn't actually work, and we call those extraneous. And the reason they have extraneous solutions is because we cannot divide by zero. It's an indeterminate value. We don't know what that means to divide by zero. But sometimes a value of x will make the original rational equation indeterminate and yet come out as a solution as we go through the solving process. So we'll talk about that as we go. Our first example here is 2 over x plus 1/3 equals 1 over x minus a half. So the first step in these is to try to clear the fraction. This is rational because there is a variable in the denominator. So the first thing I want to do is get that variable out of the denominator. And we do that by finding the least common denominator. So I look at all the denominators and I multiply them together, but I multiply them together in their smallest form. So I am going to use the 2 and the 3. Those are prime numbers, so that's as small as we can get. And then I'm going to multiply by x. Now this is x to the first and this is x to the first, so a single x is going to cover both of those. I don't want to use x squared because now I've used more than I need. Okay, so that's equal to 6x. So I'm going to multiply the entire equation by 6x. So I'm going to have 2 over x times 6x. I'm going to have 1/3 times 6x, 1 over x times 6x, and a minus a half times 6x. Now when I do this multiplication, these things are going to reduce. Okay, so these x's cancel out. The 3 will reduce with the 6 twice. The x's are going to reduce, and the 2 will go into the 6 3 times. So when I do that, that reduces the equation to 12 plus 2x equals 6 minus 3x. Now I have a linear equation in one variable, so I'm going to solve it like I always would. So that means I need to get the x's together. So I'm going to add 3x here on the right, which means I add 3x on the left, and that'll get me 12 plus 5x equals 6. Now I need to get the x alone, so I'm going to subtract 12, and that'll get me 5x equals to -6. And then I can divide by that 5, and I get x equals -6/5. So this is my solution. Okay? Now any equation like this we can check by taking that -6/5 and plugging it in where we started. And if it works, if we did our work correctly, this -6/5 should make the equation at the top true. Okay, one other observation is to make sure that I didn't make the original equation undefined or indeterminate. So in this original equation, I notice that x cannot be 0. Okay, that's the domain of that original equation. And so since this solution I got here at the bottom is not equal to 0, I'm good, I'm done, and that's my solution. So to recap, the steps we take are to find the least common denominator, multiply by that least common denominator, and then solve the equation that results. So let's go through these 3 steps again. So I'm going to find the least common denominator. So I'm going to take the denominators that I have and multiply them together. So I have a y plus 2. I have a y plus 4. Those are different and unique, so I need to use both of them. Now this quadratic here, I want to factor it before I try to multiply by it. And what I notice is that these are already taken care of. So this is my LCD. This is the smallest common denominator. So now I'm going to multiply the entire equation by that. Okay, so when I multiply this by the first fraction, the y plus 2 is going to go away. So I have y minus 3 times y plus 4. In the second equation, the y plus 2 and the y plus 4 are going to get canceled. So that leaves me with 5y. And in the last piece here, the last fraction, the y plus 4 is going to go away. So I end up with y minus 6 times y plus 2. Now I'm going to FOIL and multiply this out so that I can solve the resulting equation. So FOILing tells me I'm going to get y squared plus 4y minus 3y minus 12. The minus 5y is still there. And then I'm going to FOIL the right-hand side. And I get y squared plus 2y minus 6y minus 12. Now when I combine like terms, I end up with y squared minus, 4y minus 3y minus 5y is going to end up being negative 4y. And on the right side, I also end up with y squared minus 4y minus 12. Now notice these look exactly alike. So what's going to happen when I try to finish solving this, the y squareds are going to cancel each other out. I'm going to try to add the 4y to the other side. Well, they're going to cancel each other out. And I end up with negative 12 equals negative 12, which I could even reduce further to 0 equals 0. And so this is always true. But before I just say this is true for all real numbers, I want to double check way up the top of the problem. I need to go back and find the domain. So this right here tells me y cannot equal negative 2 and y cannot equal negative 4 because I cannot let this LCD equal 0. So my domain is x equals negative 2, not equal negative 2 or negative 4. Okay, so those two values are not in the domain. So when I get to the very bottom of the problem, my solution is not all reals, even though this is always true. My solution is x such that x cannot be negative 2 or negative 4. So we always have to check the original equation and make sure that we are still in the domain of that original equation. Okay, let's try this one more time. So again, the 3 steps are to find the least common denominator, to multiply by that least common multiple, least common denominator, and then to solve the resulting equation. So let's go through this process. The LCD for this equation is x minus 2 times x minus 3. That takes care of these two pieces. And then when I factor this, I realize that it is just those two multiplied together. So that is all I need. So then I'm going to multiply the entire equation by the LCD. So I'm writing it all out just so we make sure that we're understanding the process. So I'm going to take this LCD and multiply it by all 3 parts. I've got to multiply it by the entire equation. Now, when I do so, things in the numerator and the denominator, the factors, can cancel and reduce. So I'm left with x times x minus 3 plus 2. And then on the last one, the x minus 3 goes away, so I'm left with 3 times x minus 2. Now I can solve the resulting polynomial equation. So I'm going to distribute the x. I'm going to distribute the 3. And then I need to combine all my like terms and get my x's together. So I'm going to subtract 3x. And I'm going to add the 6. This is a quadratic equation. So if we remember from that video, we needed to get it equal to 0. Once it's equal to 0, I can factor it, use the quadratic formula, or even complete the square. This one factors nicely. X times x gives me x squared. The 8 will go to 2 and 4. The 8's positive, so they have to have the same sign, and the 6 is negative, so they're both going to be negative. So this one tells me x equals 2, and this one tells me x equals 4. So the final step is to go check the original equation. Well, the LCD cannot be 0. So my domain of this equation is x not equal to 2 or 3. So that means this value right here is extraneous. It solves the polynomial equation that I got when I reduced the fraction, but it is not allowed in the domain of the original. So my solution for this problem is simply x equals 4. Okay. Hopefully that helps give you a little introduction to rational equations and how to solve them. Don't forget the 3 steps. You're going to find the LCD, you're going to multiply by that LCD, solve the resulting equation, and then your final step is to check the domain of the original so that you don't forget to get rid of anything that's extraneous. So hopefully you'll join me next time. Our next video is on radical equations, so those with roots, square roots, cube roots, etc. in them. And we're going to figure out how to solve those. And so I hope you join me next time. Feel free to subscribe. If you're in class with me, I'll see you tomorrow. And we'll kind of go back through this lesson and see what questions you might have. But have a great day. Join me next time.